All right, so we're going to start with number 4 today, doing the universal law of gravitation. The first thing that we always do in the PGES process is find the givens and the unknown. So that's what we're going to do first. So let's read the problem before we get to that. A red planet has a mass of 1.98 times 10 to the 18th kilograms. All right, the blue planet has a mass of 4.13 times 10 to the 15th kilogram. And the gravitational force between them is 2.8 times 10 to the negative 6, so not a lot of gravitational force. And we're going to determine the distance between those two planets. So the first thing that we have to do is find all the givens in there. So let's look through this, and what are some of the givens that you see? What are some of the givens? Oopsie, let's not do that. All right, what are some of the givens that we see? What do you got? What is this thing right here? Kilograms. Kilograms represents mass. So I'm going to make this mass 1. All right, and then over here we have another mass. So I'm going to make this one mass 2. All right, and then down here we are the gravitational force. They tell you it's a force. It's in Newton, so we would know anyways. That is my force. In this case, it's the force due to gravity. And we are trying to determine the distance. This is my unknown. I'm trying to find that distance between the planets. There is one more given that's there that's actually assumed. What is that? What's the assumed given? What's capital G? The gravitational constant. It's a very small number. We talked about that before. The gravitational constant is 6.67 times 10 to the negative 11 power. If you want to do that, it is 10 zeros. 5, 6, 7, 8, 9, 10, and then 6, 6, 7. So it is a very, very, very small constant. That's why gravity is the weakest of all the 4 forces, fundamental forces. All right, the next thing that we are going to do is we have to write the equation, and we're going to have to manipulate this equation because we're solving for distance. So this is the hardest of all the problems that we're going to do. All right, so the first thing is I'm going to change the color just so I can put my equation in it, maybe green. All right, and I am going to start putting in my new equation. So my equation is the force of gravity is capital G, mass 1, mass 2. So there's my two objects that are next to each other, and this is the distance between those two objects. All right, the problem that I have right now is that the distance is squared and it's down at the bottom, and that's what I'm solving for. So I'm going to have to manipulate this this particular equation so that we're solving for distance squared. Okay, so that's kind of what's going to happen, and we're going to eventually give you that equation so that way you're able to use it easier than just using the algebra all the time. All right, so the first thing that I have to do is I have to bring this, so I'm going to make a different color just to kind of show you really quick how this works. The distance squared will go up here, and then this force of gravity, which is up here, is going to have to come back down here. So let's switch that up, and let's rewrite the equation over here. Distance squared is equal to the force of gravity, and that's going to be over gravity of mass 1 and mass 2. And then what do I have to do now? How do I get rid of that square? I have distance squared, and I don't want the distance squared, I want distance. So what do I need to do? How do you get rid of a square? Bueller. Yes, square root both sides. All right, so that's what we're going to do. You're going to take this, we're going to square root this side, get rid of that square, and then we got to square root the entire thing on this side as well. And that is going to be our equation. So it's pretty difficult as far as just manipulating the formula and working through that. All right, so the next thing I'm going to do is now that I have the equation, and I have to substitute in all my numbers. When I substitute in all the numbers, remember, every single thing goes in brackets, especially now that we have scientific notation. You want every single thing in brackets. We do not ever have to hit the multiply sign on the calculator because the brackets will do the multiplying for us. All right, so that's kind of a nice thing, is that we never hit multiply because the brackets will multiply for us. All right, so here we go. What we're going to do is rewrite this, and I'm going to have to kind of go back up and down to do this. Stop it. Stop it. Who did that? All right, here we go. All right, so the next thing I'm going to do is now start putting in the numbers where it has to go. So I'm going to put distance is equal to, and now I'm going to have to put everything in my brackets. So here we go, parentheses. All right, so the first one is my constant, which is 6.67 times 10, and I'm going to raise it up to the negative 11, and that's how I put it in the calculator. All right, and then I open up a new bracket and put my first mass, which I don't remember what it is. Let's see here. It is 1.98 times 10 to the 18. All right, so 1.98 times 10, raise it up to the 18th power, close it, open up the last bracket, and I'd have to look for the last one, which is 4.13 times 10 to the 15. 4.13 times 10, raise it up to the 15th, close it. All right, once I'm done with that, the next thing I would do is I'm going to hit enter once I do all that. So that way I have the entire thing. So I would hit enter up here. And then now I can start dividing the bottom part, which is going to be, I would hit divide after that, and then I would put the force of gravity. What is the force of gravity? It was a small number. I remember that. It said 2.8 times 10 to the negative 6. So 2.8 times 10. Raise that up to the negative 6 power, and I would close it. All right, but I'm not done yet. There is one more step I have to do after I would hit enter right here, but then I have one more step to do. So again, I would hit enter after I'm done with this, and I have one more step, which would be to square root the entire thing. So I have to square root. Once I'm done and get that number, I have to square root the entire thing to find out the answer for the distance. All right, so let's do that. I'm going to plug that in the calculator and give you the answer in 1 second. All right, so then now that we calculated doing that, we did the whole top of the thing, divided it by this, and then square root of the whole thing. It comes out to the answer is 4.413 times 10 and to the 14th power, and it's going to be in meters because it is the distance between those two places. Oh. All right, thank you so much.